Good afternoon, everyone. Welcome to this afternoon's Hazardous Waste Management Performance Workshop, number 7, Incinerable Waste, Cradle to Grave. My name's Alejandro Vivas, and I'm going to go ahead and start with some housekeeping items so that we can kick off today's workshop. First off, we're going to go over language and captions. As you can see on your screen, we have a couple of options. Today, you are welcome to listen to this presentation in English or Spanish. Since we're using Zoom, go ahead and go down to the interpretation icon at the bottom of your screen. Press that, and you'll have the option of choosing English or Spanish. If you are phoning in this afternoon, go ahead and go to your More option, which has the 3 dots, and you can go down to go down to Language and Interpretation, and you'll be able to choose English or Spanish. Next slide, please. Okay, so a couple of housekeeping items. For this afternoon's webinar, please use Google Chrome, Safari, or Firefox. It'll make this afternoon's webinar go a lot more smoothly. We've activated the Q&A box, so go ahead and use that for asking questions, and we'll go ahead and make sure we get to you in the order in which we receive your questions. Please be aware that your camera and microphone features have been disabled, but this session will be recorded, as have all our other workshops, which you are welcome to go back and take a look at our HWMP website. Now, of course, we include an end of session evaluation for everyone to fill out. That way we can know what we're doing better. What we can do better here at DTSC for our workshops. Next slide, please. The Department of Toxic Substances Control Hazardous Waste Management Plan website is available for your review, where you can get all updates and copies of this presentation, as well as past workshops, as I mentioned. You can also join our e-list for updates, and you're welcome to email us at DTSC_HWPlan, one word, at dtsc.ca.gov. Again, that's DTSC_HWPLAN at dtsc.ca.gov. You can also use the QR code on our screen, and that'll lead you straight to our website, and you can access all of the same information there. Next slide, please. So with that, I'm going to go ahead and hand it over to DTSC's Supervising Hazardous Waste Substances Engineer, Ryan Dominguez, and he's going to kick us off with our workshop schedule.
Thanks, Alejandro. Hi, everybody. Thanks for joining us today. My name is Ryan Dominguez. I'm the Supervising Hazardous Substances Engineer for the Hazardous Waste Management Plan. Today, we're having our 7th workshop of our workshop series. This series was developed to provide ongoing public education and encourage continued discussions during development of the Hazardous Waste Management Plan. These workshops discuss focused topics that are based on public feedback we've received over the last few years and provide additional information related to the development of the Hazardous Waste Management Plan. Each workshop is recorded, so if you missed any or want to go back and view the presentations again, please visit our Hazardous Waste Plan workshop page. The workshop dates and topics are subject to change, so please join our e-list to receive updates. And up on the screen, you will see the 3 workshops that we have remaining, November 6th, 13th, and 20th. So mark your calendars. Next slide, please. So first, let's start off with a quick poll for those in attendance. When it pops up on the screen, go ahead and fill that out, please. Should be a few questions. We'll give it 30 seconds or so. Okay, why don't we close that out? All right. So have you read our report? We got about 50-50. And have you attended any of our previous workshops? Yes, to about 70% and 30 for no. Okay, so at least a decent amount of folks have probably heard my introduction and just description of what we're doing. But for those who haven't, and just to touch on it again, in 2021, Senate Bill 158 was approved, and it made changes to Health and Safety Code 25135. The changes require the department to complete hazardous waste management reports that will feed information into hazardous waste management plans. In 2023, DTSC published the first hazardous waste management report, and DTSC is using that information in that report to draft the first hazardous waste management plan by March of 2025. Now, the draft plan will be presented to the Board of Environmental Safety for approval. And then the cycle starts again. This is an iterative process, and we're currently using the information in the report and the feedback that we've received over the last couple of years to develop a hazardous waste management plan. Now, the plan itself will include specific goals and recommendations that relate to the information that we're discussing throughout these 10 workshops. Next slide, please. Great, thanks. Now, as a reminder, you can access our 2023 full report on our webpage. Now, we recommend reading the full report and reviewing the appendices. Data from the report and your comments is being used to inform for development of the plan. You can access the website using the QR code here on the slide. And the report will provide a good basis for the information that we're sharing out in these workshops. Next slide, please. We've identified 4 areas of focus for hazardous waste management planning. Today's workshop is an outcome of the waste and disposal reduction focus area. I want to call back to a workshop from September 4th on pollution prevention. DTSC previously had a P2 program, but it was ended when resources were redirected to the Safer Consumer Products program. Now, since then, there's not been a program within DTSC that is focused on fostering waste reduction at hazardous waste generators. Now, as discussed during the P2 workshop, some of the goals and recommendations of hazardous waste management planning relate to taking a modern look at waste reduction. Now, in order to do this more efficiently, additional resources are needed. In the meantime, we've begun to identify and research waste streams and hope to develop strategies that can be employed to foster more reduction. Now, broadly, DTSC previously took a more direct approach to hazardous waste generation and reduction, which included review of source reduction reports, working directly with hazardous waste generators to better understand their wide range of processes and provide technical and regulatory guidance, and provided technical support for the Certified Unified Program Agencies, or the CUPAs, who are the regulatory bodies closest to hazardous waste generators. Next slide, please. Now, hazardous waste management planning offers an opportunity to recenter and redevelop a focus on hazardous waste generation and hazardous waste reduction. This begins by quantifying and understanding the industries and numerous processes that generate hazardous waste. This will also allow us to better identify opportunities for waste reduction, so alternative hazardous waste treatment technologies can be best applied. In addition, it will also allow us to determine if there are regulatory barriers to waste reduction. In 1984, Congress created the Land Disposal Restriction Program, which prohibits the land disposal of untreated hazardous waste and requires EPA to specify either concentration levels or methods of treatment for hazardous constituents. The LDR program ensures that wastes are properly treated prior to disposal. Now, this makes hazardous waste less harmful to groundwater by reducing the potential for leaching of hazardous constituents and by reducing waste toxicity by destroying or removing harmful constituents. Now, one of the three main keys to the LDR program is called the disposal prohibition. This prohibition really is the basic premise of the LDR requirements, and it requires waste-specific treatment standards to be met before a waste can be disposed to land. Today, we will discuss one of these treatment technologies and a waste stream that we recommend be a focus for reduction in planning, and this is incinerable waste. We've received a number of comments related to hazardous waste incineration and the use of incinerators. Now, there's not a commercial hazardous waste incinerator located in California, and it is unlikely to be located here in the future. Further, as you will hear in a little, there are numerous hazardous waste generators that generate waste that is required to be incinerated. These generators are located in many areas in the state, including over 120 large quantity generators that are located in vulnerable communities. Now, we are working to better understand these wastes to identify potential reduction opportunities. And with that, I will turn it over to Kayla.
Thanks, Ryan. Next slide, please. Hi, my name is Kayla Kuhl. I'm a hazardous substances engineer with the Hazardous Waste Management Plan unit. And as Ryan said, I'll be presenting today on a specific waste stream, which is hazardous waste that requires incineration as its treatment method. I'll be providing a broad overview of incinerable waste from cradle to grave. Next slide, please. Incinerable waste is a waste stream that gets a lot of attention, and we think that it's worth further analysis. The Hazardous Waste Management team has recommended that this be a waste stream that is studied for reduction. In this workshop, we are going to be discussing the generation of incinerable waste and how incinerators work. We will also be exploring incinerable waste source reduction and potential alternative management for waste requiring incineration. As always, we want to hear from you, so we will be ending this workshop with a public feedback session. Next slide, please. Looking at the agenda with a bit more detail, we will be starting off with the requirements of the Hazardous Waste Management Plan and how incinerable waste ties into that. We'll be moving into a discussion of generation data from California, including the types of incinerable waste being generated, top generating industries, and the locations of generators. We'll move into a discussion of what incinerators are, how they work, and the regulations they operate under. Then, I'll be discussing the potential for alternative technologies to use instead of incineration, and both the limits of these technologies and the potential regulatory concerns. Finally, I'll be discussing ideas for reduction efforts of incinerable waste. Next slide, please. So let's start off with the requirements for the Hazardous Waste Management Plan and why we are analyzing waste requiring incineration specifically. Next slide, please. SB 158 is the statute that determines the contents of the Hazardous Waste Management Plan, and it requires that the plan make recommendations on how to reduce the amount of hazardous waste generated or disposed of. This includes goals on particular waste streams or hazardous waste types. For this iteration of the plan, we have recommended that hazardous waste requiring incineration as its treatment method be targeted for reduction. Waste requiring incineration is generated by a variety of industries, and even some household hazardous waste is managed by incineration. I will be going into generation data more in a bit, but first let's look more into why we have prioritized incinerable waste for reduction. Next slide, please. Incinerable waste only makes up about 3% by weight of hazardous waste manifested in California. So it's not that large of a waste stream compared to others, but incinerable waste may be a good target for reduction for several reasons. Even though 81% of California's hazardous waste overall is non-RCRA and therefore only hazardous in California, those numbers are basically flipped for incinerable waste, where 78% of incinerable waste is RCRA and therefore hazardous federally. So even if that waste goes to other states, it must still be treated in a hazardous waste incinerator. As Ryan mentioned, there are no commercial hazardous waste incinerators in California, and it is unlikely that any will be proposed. There are limited incinerators nationwide. The 2020 global pandemic also triggered a series of events that disrupted the hazardous waste management system nationally. In 2021, the US EPA sent a memo that they became aware of a backlog at the hazardous waste incinerators, and some facilities would no longer accept hazardous waste designated for incineration. This backlog created a national issue with managing these hazardous waste streams. Our team has been communicating with the US EPA to monitor the situation, and even though there are signs that this backlog is improving, it has yet to fully resolve. So reduction in incinerable waste is more important than other types of waste from the perspective that there is very limited management capacity. Another reason we're looking at incinerable waste specifically is because these wastes may have potential for negative community impacts. This is in comparison to something like contaminated soil, where if you're removing contaminated soil during a site cleanup, that's considered a positive impact to the surrounding community because you've removed the contamination. Typically, the focus when discussing incinerable waste is on the incinerators themselves, but we also wanted to research the generators of incinerable waste. Some generators are located in SB 535 disadvantaged communities, which I'll be discussing later in this presentation. So the potential health and environmental impacts of incinerable waste are another reason this waste stream is being prioritized. Next slide, please. Let's dig more into the capacity shortfall. This is a map of all operating hazardous waste combustors, which includes incinerators in the United States. Those large kind of greenish teal dots are the incinerator combustor locations. Please note that there are also small black dots for a few cities that don't represent these locations. This map is from the US EPA's website. Now, I want to note here that there's two different terms. There's the term combustor and there's incinerator. And those sometimes are used interchangeably, but they have different technical definitions. Incinerators are used to burn hazardous waste primarily for waste destruction and treatment purposes, though some energy or material recovery can still occur. The term combustor is broader and includes not only incinerators, but also facilities where waste is destroyed, but substantial energy recovery occurs as well. The facilities that are primarily for energy recovery are called boilers and industrial furnaces, or BIFs. One type of BIF is cement kilns that burn hazardous waste as fuel. So this map shows both the incinerators and the BIFs, since both are types of combustors that burn hazardous waste. This map only shows commercial facilities, which are those that accept waste from other companies to be incinerated. There are additional facilities nationwide called captive facilities because they're owned by a company and they only incinerate waste produced by that company specifically. As you can see, there are very few facilities in the entire western half of the United States and none in California. There's more in the eastern half of the country, but they're still pretty limited, which is why there's a capacity shortfall for incinerating hazardous waste. Next slide, please. Imbalances in the hazardous waste management system can have impacts to Californians and their communities. First, it can lead to illegal disposal. This photo shows 2,600 gallons of illegally abandoned hand sanitizer dumped in the Lucerne Valley in September of 2023. During the pandemic, there was a large ramp up of production of hand sanitizer to help protect people from the coronavirus, but as their expiration dates passed, that hand sanitizer became an ignitable hazardous waste. As we discussed on our last slide, there is limited incineration capacity, and this lack of capacity in part could have contributed to this type of illegal mismanagement. I don't want to imply that an excess supply of capacity will stop all illegal mismanagement issues. Hazardous waste is expensive to dispose of, so some people will always break the law even if there is excess capacity. That being said, the lack of capacity can contribute to these types of issues. Also, if other states had no hazardous waste incinerators like California does, then there wouldn't be any legal way to dispose of hazardous waste requiring incineration. And while there will always be potential impacts from the generation and proper management of hazardous waste, the impacts of illegal disposal will be worse. Second, there can be impacts to federal funding for new Superfund cleanup projects. The Comprehensive Environmental Response, Compensation, and Liability Act, known as CERCLA, authorizes the US EPA to respond to releases of hazardous substances into the environment. One of the amendments of CERCLA includes Section 104C9, which requires states to assure the future availability of hazardous waste management capacity before new CERCLA trust fund money can be used for remedial actions within a state. States can either ensure that they have capacity within the state or through agreements with other states. So the US EPA could choose to withhold new CERCLA funds if it determines states do not have an adequate capacity for the next 20 years. I want to note here that though California, of course, does not have a hazardous waste incinerator, a shortage of hazardous waste management capacity is a national issue. It is not one unique to just California. In summary, waste requiring incineration as a treatment method has been targeted for reduction because there are no incinerators in California and very few nationwide. So there is a national capacity shortfall. If California does not address our capacity shortfall, then there is a potential for new CERCLA funding to be endangered. We also need to do further research into the potential impacts that waste requiring incineration has. We do know that if there isn't adequate capacity for legal hazardous waste management, then there will be negative impacts from the illegal disposal of that waste. Next slide, please. So let's move into a discussion of the incinerable waste being generated in California. Before we discuss reducing incinerable waste generation, it's important to know what the waste streams are, what industries are generating it, and where the generators are located. Next slide, please. Let's start off with an overall generation trend. This graph shows the incinerable waste generated between 2010 and 2021. As you can see, there doesn't seem to be any clearly or increasing or decreasing generation. The generation looks a little higher than 10 years ago, but not enough to clearly see an increasing trend. And there's a decent amount of fluctuation from year to year. Next slide, please. Next, let's look at what industries are generating waste requiring incineration. To try and understand where incinerable waste is being generated, the North American Industry Classification System, NAICS, was used to sort incinerable waste generated between 2010 and 2021. This graph shows the top 7 NAICS codes for incinerable waste, and all other sectors outside of those top 7 are in the gray block at the bottom left. However, the top stream is in pink at the top left is waste management and remediation services. This represents the management of incinerable waste and not the generation, so it's obscuring the actual industries generating these wastes. The second highest category, besides the ones combining everything not in the top 7 streams, was rail transportation, which is also likely related to the transportation of incinerable waste and not the generation. The reason that these industries are being shown as the generators of this waste is because of how our team processes hazardous waste manifests. Often, wastes are sent from many generators to a transfer facility that combines them by waste type before shipping them to the incinerator. To avoid double counting, since a new manifest is created at the transfer facility prior to going to the incinerator, our system doesn't show the initial shipments to the transfer facilities and only shows the final shipment from the transfer facility to the incinerator itself. However, the other top categories in the top 7 provide more insight into incinerable waste generation. These are chemical manufacturing, petroleum and coal products manufacturing, transportation equipment manufacturing, professional, scientific, and technical services, and personal and laundry services. These are the industries that we are going to be researching to better understand the generation of incinerable waste going forward. Next slide, please. To further understand incinerable waste generation, we looked at the top 5 RCRA wastes requiring incineration in 2021. As a reminder, RCRA is waste identified as hazardous federally. It is not hazardous waste only in California. It's probably not surprising here that the top code is D001 for ignitable hazardous waste, since burning the waste in an incinerator will remove the characteristic that made it hazardous. This is a broad category of many wastes. Looking at the NAICS codes generating D001 waste, it seems like it matches the overall trend for incinerable waste, with the top categories being waste management, transportation, and chemical manufacturing. One interesting thing, though, is that the 4th largest industry generating D001 waste is hospitals and related services, which does not show up as one of the top NAICS codes overall. This may be like sanitizer being incinerated, but this may require future research. The other top waste streams are D007 for chromium waste, F003 for non-halogenated solvent waste, and non-halogenated solvents include things like methanol, acetone, also blends of solvents that are non-halogenated. The 4th category is D035 for methyl ethyl ketone waste. And the 5th is D005 for barium waste. We know in general what industries are generating these wastes, but more research is needed to determine which industries are generating specific categories within these waste codes. D001 especially requires more research because it's the top waste stream, but also because there is a wide variety of wastes that fall into that code. Next slide, please. Most hazardous waste being incinerated is required by RCRA, but we also polled the top 5 non-RCRA incinerable waste for 2021 to better understand why some wastes are only hazardous in California, but still managed by incineration as treatment. The top waste stream is 612 for household waste. This is extremely ambiguous from the name, but it can include things like aerosols, gasoline, and paint. The second highest waste stream is 343 for unspecified organic liquid mixture, which is also pretty vague, but can include paint as well. The third highest waste stream is 331 for off-spec, aged, or surplus organics. So that tells you why it's a hazardous waste, but it doesn't tell you what the chemicals are under that umbrella of being off-spec or past expiration date. The 4th largest waste stream is 352 for other organic solids, which is also extremely vague and non-descriptive, but can include spent refinery carbon, painted materials, and solvent-contaminated debris like spill cleanup wipes. The 5th largest non-RCRA waste stream had a blank for the waste code, so that's representing errors in our manifest system. Next slide, please. Let's look at where incinerable wastes are going. As you can see, the pattern of out-of-state destinations mostly follows where the incinerators are located. In general, the larger the dot here means the more tonnage of incinerable waste received, though it's not perfectly proportional. There are some smaller dots in areas that do not have hazardous waste incinerators, including in-state. These may include transfer facilities where waste is being combined, but we need to research that further. The numbers on this graph are the tons of incinerable waste sent to each facility. They are rounded to the nearest ton. So dots that have a 0 next to them received a little bit of incinerable waste, but it was less than half a ton, so it rounded down to 0 when rounded to the nearest ton. Not particularly surprising, the closest hazardous waste incinerator to us in Utah received the most incinerable waste in 2021 at 24,000 tons. The next closest facility to us in Nebraska received the second highest amount at 12,000 tons. Several other incinerators in the eastern half of the country also received large amounts of California-generated incinerable waste. Next slide, please. We calculated the distance from generators to destination facilities. The 2023 Hazardous Waste Management Report included a calculation of the average distance between generators of manifested hazardous waste and the destination facilities receiving that waste. The distance was calculated using information from Hazardous Waste Manifest between 2010 and 2022 between each generator and destination facility, which accounts for the curvature of the earth, but not any actual physical roads taken. So this is an average direct distance, but could be called an as the crows flies distance. The average direct distance between generators and destination facilities for all Californian manifested hazardous waste was calculated to be about 500 miles. And as mentioned, this is not the actual routes taken, just the physical distance between the 2 points and the curvature of the earth. The actual distance traveled, of course, will always be larger than the calculated ideal distance, though exactly how much larger may vary. The calculation was repeated for waste requiring incineration specifically, and the average distance between generators and destination facilities was found to be 1,000 miles, twice the overall average distance hazardous waste traveled overall. This isn't surprising because for other waste types, California can handle a lot of its hazardous waste in state, and that's going to bring your average down. For waste requiring incineration, the commercial hazardous waste facilities are located out of state. Due to its incinerator backlog, the incinerators located closest to California may not be accepting waste at a given time, requiring the waste to travel even further. I want to note here that a lot of these longer distances for hazardous waste transportation take place on trains, or at least partially on train. You may have a truck bring waste from a generator to the nearest train. However, it's still worth noting, of course, the longer distance traveled, even if it is in a train, still means more greenhouse gases being emitted for the transportation of that hazardous waste. Next slide, please. Let's look at large versus small quantity generators. Large quantity generators are those that generate more than 12,000 kgs of hazardous waste per year. Though for this analysis, we were specifically looking at generators generating 12,000 kgs or more of waste requiring incineration specifically. Only 4% of facilities generating incinerable waste were large quantity generators, or 282 out of 7,782 facilities total. However, these large quantity generators still accounted for about 90% of the incinerable waste being generated in state, at about 48,500 tons of incinerable waste being generated by those large quantity generators versus 54,000 tons total. So despite being only a relatively small number of facilities, large quantity generators dominate the incinerable waste generation in California. Sorting by large versus small quantity generators doesn't give particularly good insight into what these industries are. Often, large quantity generators may be businesses like refineries or chemical plants. However, since there are so many small quantity generators, there needs to be more research into what those industries are and if there is a potential for community impact. However, DTSC does not have authority over local zoning decisions with regards to the locations of businesses. Next slide, please. Let's look at the locations of these large quantity generators. In SB 535 designation, Cal EPA formally designated 4 categories of geographic areas as disadvantaged. 1, census tracts receiving the highest 25% of overall scores in Cal EnviroScreen. 2, census tracts lacking overall scores in Cal EnviroScreen due to data gaps, but receiving the highest 5% of Cal EnviroScreen cumulative pollution burden scores. 3, census tracts identified in the 2017 designation as disadvantaged regardless of their scores in Cal and Virus Green. And 4, lands under the control of federally recognized tribes. This map shows SB 535 tracts in purple and large quantity generators as black dots. In 2021, 45% of large quantity generators were in SB 535 communities. So there are many large quantity generators of incinerable waste located in SB 535 communities, but a majority are not located in SB 535 communities, a slight majority. Please note that data is an estimate and not all facilities may be represented. As discussed earlier, transfer facilities that accept hazardous waste prior to sending it to a destination facility obscures the location of some hazardous waste generators. Because of this data gap, there may be some generators not counted on this map because they sent their waste to a transfer facility and therefore are not shown in our analysis as generating the waste themselves. Now, we do see these facilities in our system, but we don't see them sending their waste to an incinerator because we see them as sending it to the transfer facility. So not the final incinerator. There may also be transfer facilities shown on this map that do not generate the hazardous waste themselves, but are considered large quantity generators in this analysis because of the amount of hazardous waste they accept. Next slide, please. Yeah, I know that zoomed out map was kind of hard to really appreciate the locations of things. So we did a couple of zoom ins on some of the population areas. So this is the section of the map showing the Bay Area and the Sacramento area. And, in general, the generators of incinerable waste are congregated in the areas of densest population. And this is a trend that we see for all types of generators of hazardous waste, not just incinerable waste. Next slide, please. And here's a zoom in of that same map in Southern California. Now you can see on this map very clearly, there's a pretty substantial cluster of large quantity generators that are located in SB 535 communities near Los Angeles. Next slide, please. We've discussed the cradle of incinerable waste in terms of generation. Now let's look at the grave for this waste, which is the incinerators themselves. Next slide, please. So let's start with the question, why do some hazardous wastes require incineration? Many hazardous wastes required incineration per RCRA because that is considered the best demonstrated available technology, or BDAT, for treatment of that waste. This is defined as the treatment technology that best minimizes the mobility or toxicity of the hazardous constituents for a particular waste. It's important to note when I'm talking about best demonstrated available technologies, available meant that it had to be commercially available on a decently wide scale. So I'll be talking more about SWO later in the presentation, but at the time, SWO was not considered commercially available, so it could not be the BDAT for this waste. Next slide, please. So the BDAT has to either decrease the mobility or the toxicity of a hazardous waste, ideally both. Incineration reduces the toxicity of waste by destroying volatile organic constituents. Mobility is also decreased. You can incinerate a liquid waste such as a solvent and produce a solid ash. Liquids can't be disposed of in landfills because they're mobile and they're very difficult to contain even with liners, but ash is less mobile, so it's easier to contain. Incineration also substantially reduces the volumes of these wastes. Next slide, please. This is a very simple diagram of what happens in an incinerator. It's from a Citizen's Guide to Incineration published by the US EPA. This is just meant to be a process flow of what's happening during incineration. It doesn't represent any specific incinerator and it does not show any technical details. So in the top left, you have a contaminated waste entering the incinerator. Some waste need preparation prior to this though. such as if they have a lot of excess water present or large debris like rocks that wouldn't be able to be incinerated. The materials are then placed in the combustion chamber of an incinerator where they are heated to an extremely high temperature for a specified period of time. The temperature and length of time required depend on the types of waste and contaminants present. Air or pure oxygen may be added to the chamber to supply the oxygen needed for burning. As the waste heats up, the contaminants change into gases and most are destroyed. Gases that are not destroyed pass through a secondary combustion chamber for further heating and destruction. Ash is produced as a byproduct. The resulting gases that are not captured then pass through the air pollution control equipment, which removes particulate matter, and the particulates might be very small solid particles like airborne ash, or they could be liquid droplets. And it also removes acid gases, which include things like nitrous oxide. Next slide, please. Incinerators are extremely hot, operating between 1600 and 2500 degrees Fahrenheit. It's really difficult to even comprehend how hot that is, except for to say that a standard fireplace burns between 500 and 1100 degrees Fahrenheit, so a good deal less. The length of time needed inside the incinerator is going to vary significantly. Solid waste take longer to burn and may have residence times of 30 to 90 minutes, while liquid wastes are incinerated in mere seconds. There are regulatory controls for emissions which are met by using air pollution control devices, which I'll discuss more on the next slide. Next slide, please. My apologies for the image quality here. This was taken from an EPA training. There are many different types of air pollution control devices, including ones that physically filter out particulates and those that address gaseous emissions. Particulate matter control can include filters and Venturi scrubbers. Gaseous pollutant control can include other types of scrubbers and activated carbon absorbers. This slide shows a schematic diagram of a Venturi scrubber from an EPA training on air pollution control. The dirty gas enters the scrubber and the Venturi, which is a reduction in area of the duct, increases the speed and turbulence of the pollutant particles. At the throat of the Venturi, the particles interact and combine into larger particles. From the throat, the area of the duct increases, slowing the gas down as it enters a cyclone separator that allows the speed to be reduced further and the particles to fall out. Clean gas exits the scrubber. Next slide, please. Incinerators have very tight control standards. The general destruction of organic constituents must be 99.99%. Dioxin destruction has stricter standards and must be 99.9999%. Particulate emissions must be less than 180 milligrams per meters cubed. These standards have been designed to be protective of human health and the environment. These are RCRA requirements. There may be additional air pollution requirements in California, depending on the air pollution control districts, but we have not researched those additional requirements. Next slide, please. There are many concerns about incinerators. Incineration facilities serve as destinations for large volumes of hazardous waste. The incineration process can produce extremely harmful products such as carbon monoxide, nitrous oxides, dioxins, and other dangerous chemicals. Though, as I mentioned, incinerators have air pollution control devices and are governed by emissions regulations, there are still concerns about even low levels of emissions of these chemicals. Because of these concerns, it's extremely difficult for the construction of a hazardous waste incinerator to be approved. This has resulted in a shortage of hazardous waste incinerators compared to the generation of waste requiring incineration, as I discussed previously. Next slide, please. Incinerable waste may benefit from alternative treatment methods. For example, supercritical water oxidation, also known as SWO, has been proven effective at treating some incinerable waste. We know from feedback we've received that there's a lot of interest in this technology, and we even visited a facility that demonstrated SWO for us. The demonstration was for PFAS-containing waste, which is not a hazardous waste. But the technology could also be used for hazardous waste destruction and has been proposed as an alternative treatment for waste which otherwise would require incineration. However, the technical and regulatory limitations of SWO and other alternative technologies may be a primary driver of why these technologies are not widely used. As new alternative technologies are researched, we will also continue to research potential regulatory restrictions on these technologies. Next slide, please. So SWO stands for supercritical water oxidation, and water can be made supercritical at extremely high temperatures and pressures, above 705 degrees Fahrenheit and 3,206 PSI. Supercritical water exists as a single dense phase that moves through media like a gas, but has solvent properties more like a liquid. Also, water undergoes a change in its solvent behavior once it becomes supercritical. This allows supercritical water to be able to destroy organic wastes when normally organic wastes are not soluble in water. Next slide, please. Supercritical water oxidation has been used on a small scale for about 40 years as a treatment technology for aqueous-based organic waste. The SWO process allows for the rapid destruction of a wide variety of organic species that are normally considered difficult to break down. Corrosion and salt precipitation are the two biggest challenges in SWO processing. There have been many companies that have used SWO technologies that are no longer in business. And poor management of corrosion and salt plugging is likely the technical reason that some SWO companies have shut down. Next slide, please. There are still some companies using SWO technology, but it doesn't seem to be widely used for hazardous waste. So it has been used, though, for the treatment of municipal wastewater for PFAS. These two images on the slide, it's sorry for the small text, but they're just brochures that these companies have produced advertising their technical capabilities. Battelle, 374 Water, and General Atomics are companies that have achieved success in PFAS destruction. However, while PFAS are not hazardous wastes, SWO could in theory be applied to many hazardous wastes. So this is a developing field that we wanted to learn more about. Next slide, please. General Atomics invited both regulators and industry members to their San Diego facility for a demonstration of industrial supercritical water oxidation, abbreviated ISWO. This photo shows the unit we visited, which is their permanent demonstration facility in San Diego. As you can see, it's relatively small scale with only a few pieces of equipment, though there's also a few pieces of supporting equipment not in this photo because they're outside, like the air compressors and the separator. General Atomics also offers SWO technology in mobile units, and that's possible because it is relatively simple in terms of the pieces of equipment that you are using. Next slide, please. The schematic of an ISCO unit is shown on this slide. A waste is added to a water and fuel blend as shown on the upper left of the diagram, which is fed into the ISCO pressure vessel in the center, which operates at 3,400 PSI and 1,200 Fahrenheit, which is above the minimum of 3,200 PSI and 705 Fahrenheit needed for supercritical water. This is this slightly higher than necessary conditions is to just ensure the high destruction efficiency of organic materials. Under these conditions, organic materials, oxidation reactants, and oxidation products are rendered miscible in water, which means they form a homogeneous or uniform mixture. This allows complete oxidation to take place at a really high rate. Only 3 to 4 seconds of residence time is needed for destruction, though the setup they demonstrated had a 10 to 12 second residence time to allow for a margin of error. Water, shown in the bottom left, quenches the resulting material. Pressure is relieved and the material enters a gas-liquid separator on the right. The gas effluent on the upper right usually only contains emissions such as excess O2, oxygen, carbon dioxide, and steam, though the gas effluent does pass through emissions stack for testing. The liquid effluent on the bottom right is sampled and typically can be released into the municipal wastewater system, though sometimes it does need adjustment first. Next slide, please. And that picture is actually one of the ISCO mobile units. The purpose of this visit was for General Atomics to advertise how their technology can be used. SQUO can be used on a wide variety of feed materials, including spent activated carbon, fluorinated organics, fuel oil, mining waste, and resin beads. The specific demonstration they provided was on the destruction of PFAS. When incinerated, PFAS and other fluorinated compounds release hydrogen fluoride, which is extremely hazardous. But SQUO fluorinated waste did not detect hydrogen fluoride in the effluent stream after neutralization. That being said, it was present pre-neutralization. I mentioned earlier that corrosion and salt plugging tend to be the two biggest issues in managing SQUO. General Atomics noted that some corrosion is seen on their equipment, but their reactors have a replaceable liner, which is relatively inexpensive compared to the total cost of the reactor. This liner material can be selected based on the feed that is being processed, so the most resistant material possible is used, and replacement of the liner takes place only in a few hours. Also, because ISCO uses a vessel reactor that's about 10 to 12 inches in diameter, instead of a narrow pipe reactor like other companies have used, the issues of salt plugging are minimized because even if there's a little bit of salt buildup on the walls, it's not plugging the reactor. Next slide, please. As mentioned earlier, there are no commercial hazardous waste incinerators in California and a national capacity shortage resulting in a backlog of waste needing incineration. There are issues citing additional incinerators or even expanding existing ones. So the national capacity is unlikely to significantly increase. However, supercritical water oxidation systems may have more public acceptance than incinerators, so there is more of a possibility of them being built in California, though of course they would still need to go through California's permitting process. Based on conversations with General Atomics, the byproducts of ISCO are typically non-toxic compared to an incinerator. This is a technical advantage of ISCO over incineration, but it could also possibly make ISCO easier to permit. However, it's really difficult to make generalized statements of the byproducts of SQUO versus incineration that are applicable to all waste streams that might be processed. For a given waste stream, the byproducts of SQUO could be modeled in a computer, but you would need small-scale testing to determine the byproducts of SQUO with certainty. Next slide, please. ISCO has some challenges to implementation. There is a high upfront equipment cost to implementation, including not only the ISCO equipment itself, which is estimated to cost approximately $3 to $5 million, but also supporting items such as the building to house the unit, utilities, electricity, and wages. This doesn't account for any costs or the time investment associated with permitting a hazardous waste treatment unit in California. However, I don't want to imply that incinerators aren't also expensive, although, as I'll describe more later, incineration does occur at a far larger scale than SQUO. We don't know how much an incinerator would cost because none have been built recently, but just to get a very ballpark estimate of cost, there was a relatively recent incinerator expansion that increased capacity by 70,000 tons of hazardous waste yearly for an incinerator, and that expansion cost $120 million. So it's also very expensive. We also don't know how much a boiler or industrial furnace would cost, but those cement kilns and other boiler and industrial furnaces do get to offset their costs a bit by getting energy value back from the burning of hazardous waste. With SQUO, there wouldn't be any offsets to the high cost by energy recovery. There are also some restrictions to the physical nature of feeds that can be processed by an ISCO unit. Solid feeds can be used, but only if they can be suspended in a slurry. Large solid feeds like used spill cleanup wipes or other contaminated debris could not be processed with SQO. Another concern is whether SQO would be allowed under RCRA hazardous waste regulations because of land disposal restriction requirements. Most incinerable waste generated in California is RCRA and hazardous federally, not non-RCRA and only hazardous in California. So for those RCRA hazardous wastes, RCRA treatment standards must be followed. SQO does not appear to be an approved treatment method for RCRA hazardous waste, but we're looking into this further because the treatment standards do not appear to apply if only wastewater that can be discharged into the municipal wastewater system is created as a byproduct, because you don't have land disposal that way. There also may be a difference between the regulations for on-site treatment and off-site treatment. And since ISCO units are portable, on-site treatment might be a possibility, though of course it would still require a permit in California. ISCO does not appear to be an approved technology for lower tiered permits. So this could be an opportunity for California's lower tiered permitting options to be amended to include additional treatment technologies and encourage more treatment of waste on-site versus shipping it off-site. This is an area of future research for us. Next slide, please. One of the biggest disadvantages of ISCO compared to incineration is throughput, and that's how much material you can put through the system in a given period of time. ISCO operates at a feed flow rate of 3 gallons per minute. The system is theoretically capable of running up to 5 gallons per minute, but this is typically not the case. Also, some feed materials run at less than 3 gallons per minute, depending on the energy content of the feed. So the exact feed flow rate is going to be specific to the type of waste being processed. I did a very rough back of the envelope calculation of ISCO throughput. I assumed a typical 3 gallon per minute feed flow rate, but I also assumed 0 downtime in a year and 24/7 operation. I picked a very rough assumption for material density. Of course, that would also vary pretty significantly depending on waste type. But using these numbers, I got that a single ISCO unit could process about 5,000 tons of hazardous waste per year. In comparison, the hazardous waste incineration facility in Aragonite, Utah, typically processes more than 10 times as much hazardous waste per year at over 60,000 tons. It's permitted to process even more waste at 162,000 tons per year per the EPA. Like I said, this is a very rough comparison, and it relies on a lot of assumptions for the ISCO calculation. The most any ISCO unit has been demonstrated to run is Monday through Thursday continuously, so 24 hours a day, but only 4 days a week instead of 7. This cuts the estimate down to only about 3,000 tons of material processed a year. This also does not include any downtime, either planned or unplanned. This is just to give you a very rough comparison of the throughput of a SQO system versus an incinerator. One potential way to combat the issue with throughput would be to have multiple SQO units operating in parallel, but that's currently not being done. It's also not clear if the SQO vessels themselves have scale-up potential that would allow for a higher than 3 gallon per flow rate. The vessels are currently fairly small, but there are issues with increasing wall thickness as you scale up a pressure vessel. Also, ISCO would not be able to create non-hazardous compounds from metal-bearing waste such as chromium sludges, so those wastes would still require a different treatment. Next slide, please. In summary, General Atomics invited us to view a demonstration of their industrial supercritical water oxidation. The system uses the unique properties of supercritical water to destroy a wide variety of waste materials, including hazardous waste. The ISCO system produces minimal byproducts. At the time of our visit, General Atomics demonstrated the destruction of PFAS in firefighting foam, which is not a hazardous waste, but the technology has potential for other waste streams, including hazardous waste that otherwise might be managed by incineration. General Atomics has proposed that ISCO could be a potential alternative to incineration, given the issues citing incinerators. However, we are still researching the potential regulatory limitations to use of this technology. At a minimum, it would require hazardous waste treatment permit under California regulations. Also, while ISCO is apparently technically capable of handling many of the same waste currently treated with incinerators, a single ISCO system running at ideal conditions produces can process less than 1/10 the hazardous waste that the nearest incinerator does. SCWO is currently not a large-scale or widely used technology. Also, it would require a company wanting to build and operate a SCWO system for hazardous waste destruction. So there's a lot of additional unknowns that would need to be researched before fully understanding the potential of this technology. Next slide, please. We studied SCWO in detail because of the interest in the technology from the feedback that we have received, but also because General Atomics invited us to see their demonstration facility. That's not the only potential alternative to incineration, though. Pyrolysis is another thermal decomposition process, but unlike incineration, takes place in the absence of oxygen. Many of the concerning byproducts of incineration are less likely to form without the presence of air or oxygen. For example, a study on the municipal waste showed that incineration formed 7 to 20 times more dioxins than pyrolysis did. So basically a whole order of magnitude more dioxins formed in incineration than pyrolysis. Pyrolysis also has its own limitations, such as feed size requirements and the need for low moisture content of the feed. Wet air oxidation is used on waste streams that are too dilute to incinerate, but too concentrated for biological treatment. Wet air oxidation uses oxygen or air at high temperatures and pressures to break down complex molecular structures into simple components. The temperatures, pressures involved are high, but still far lower than those used in supercritical water oxidation. However, like SCWO, there are high upfront capital costs to wet air oxidation, and there are still issues with salt plugging and corrosion of the equipment. So in summary, there are some potential alternatives to incineration, some of which may have fewer environmental concerns than incineration does. However, there are technical and regulatory limitations that may be preventing these technologies from being as widely applicable as incineration is. Next slide, please. All right, so let's look forward for a bit and let's talk about ideas for future waste reduction efforts. Next slide, please. If you attended our workshop on the pollution prevention program that used to be existing at DTSC, you're probably familiar with the Incinerable Waste Minimization Project. And you may have heard about it anyway, even if you didn't attend that workshop, because it was a major success for the program. There were still back then no commercial hazardous waste incinerators in California, so all waste requiring incineration must be shipped out of state. Because of this, incinerable waste was noted as a focus area for reduction all the way back in the 1989 capacity report. So this became a major project for the P2 program. The P2 program identified 57 facilities generating large amounts of incinerable waste that were identified as top priority. Of those 57 facilities, 39 signed a voluntary agreement to work with DTSC in exchange for technical and regulatory assistance. 5 years later, in 1992, those 39 participating facilities had reduced incinerable waste generation by 53% compared to 1987. Numerically speaking, this was 92,000 tons of incinerable waste reduced to about 43,000 tons. These generators were able to reduce their incinerable waste in a variety of ways. For example, one aircraft company used a corrosion
Una compañía de aviones utilizó el catalizador de pintura corrosiva solamente de 8 horas y la pintura dentro de esas 8 horas había que eliminarse. Debido a que menos de 2 onzas de pintura, la compañía pasó a contenedores de 2 a 4.
Being wasted every single shift. The significant reduction of incinerable waste was a major success for the P2 program, but also for the businesses that participated in the project. Now, I just want to note here that, we're talking about the late 80s and early 90s. In many cases, these companies that were able to significantly reduce their incinerable waste through this project, they had very poor waste reduction and efficiency practices. So it wouldn't necessarily be expected that future waste reduction programs would be able to achieve such large reductions because many easy reduction techniques have already been used at this point. So let's talk about some challenges to reduction. Next slide, please. Hazardous waste is expensive to treat. So companies have a natural incentive to reduce generation. That means that hazardous waste being generated has some sort of an obstacle for its reduction. Now, some of these obstacles may be easier to overcome than others. For example, many small businesses, they may not have staff dedicated towards efficiency, and they could have their hazardous waste generation maybe reduced just by having an efficiency study conducted. For other companies, capital may be the issue. For example, updating their equipment to more efficient equipment, or equipment that doesn't produce waste requiring incineration. However, there are still limits to efficiency and substitutions because some chemical processes are inherently going to produce incinerable waste. There are other reasons that reduction may be difficult. Just as an example, prior to working for DTSC, I worked in pharmaceutical manufacturing. Pharmaceutical manufacturing is very tightly regulated by the FDA, and companies aren't allowed to make any changes to their processes outside of approved ranges, even if those changes would result in greater efficiency and lower waste generation. Making changes would require an expensive and lengthy process to refile the pharmaceutical drug with the FDA. Now, these regulations that the FDA has that are limiting these changes, they're very important to protect human health because changes to manufacturing processes could result in unintended and sometimes undetectable changes to the final pharmaceutical product. However, these regulations do make it extremely difficult to improve efficiency. Now, that's just one example of an industry that faces unique issues with waste reduction. Other industries may have their own unique barriers to waste reduction. And that's going to be something that we're researching further. Next slide, please. The Hazardous Waste Management team has recommended incinerable waste as a target for reduction, but further research is needed to determine how that reduction could take place. DTSC does not currently have a P2 pollution prevention program like it used to. This program was important because DTSC had internal expertise on hazardous waste generating industries and could use that expertise to work with generators on reduction. A reimagined P2 program could reestablish that expertise, which would be needed to help encourage voluntary reduction from generators. Without receiving additional resources to reform a P2 program, DTSC can still pursue pollution prevention, but of course it would be at a much smaller scale. Next slide, please. In summary, incineration is a necessary part of modern hazardous waste management. There are concerns about the potential health effects of incinerators, which has resulted in few of them being built, but the health effects of not incinerating the hazardous waste and it being improperly or illegally disposed of would be far greater than the health effects of the incinerators. That being said, incinerable waste is a good target for reduction. Reduction of incinerable waste would reduce the burden on our current management capacity while reducing the potential health impacts of the incineration process. In addition to reduction in generation, alternative technologies to incineration are an important area of future research. Next slide, please. All right, well, thank you so much, everybody, for sticking with me through that presentation. We'd like to open the floor now for public feedback.
Thanks, Kayla. We do have some questions here in the Q&A box. Thanks again, folks, for using that box. It does help us answer things more efficiently and for our transcripts. Also, with our transcripts, I'm going to go ahead and read these out loud so that they are recorded and they all are also translated in real time. So first, coming from Chris Bryant, I noticed that D005 and D007 waste codes are listed in the top 5 incinerated RCRA wastes. Doesn't the LDR dilution provision 268.9 prohibit the incineration of inorganic metal-bearing wastes?
I'll take that one. Thanks, Chris. Short answer is I'm not sure. We're right at the beginning of research in this waste stream, and that's a fairly specific question to the specific waste codes. So kind of illustrates why this is an ongoing and iterative process that we're in. So thank you for that question, and we'll take that back and look at it. I don't know. It'll probably fit into like the next reporting cycle, kind of when we're planning to dive deeper into some of the waste codes and this waste stream in particular, and at that time. So thank you.
Thanks, Ryan. From an anonymous attendee. Hello, some incinerators are not accepting products that contain iodine like betadine and providone due to stricter environmental regulations, which require regular emissions monitoring and reporting. Do you know if this is a federal or state requirement?
I'm not sure about that one either.
I'm not either. That's another area of future research to look into those specific products.
Okay, coming from another anonymous attendee, why isn't PFAS considered hazardous waste? Does it pass the 96-hour acute aquatic toxicity test?
I'll start with the second question first. I'm not sure if it passes the 96-hour acute aquatic toxicity test, and that's a California test. It's not a federal test, and I'm not sure. And then why isn't PFAS considered a hazardous waste? EPA has proposed to list 9 constituents as hazardous constituents. They haven't yet talked about the listing or putting characteristics or testing methodologies together for the hazardous waste that we've heard about. So why is it not a hazardous waste? Well, it's not listed and it doesn't fail one of the characteristics.
Okay, and coming from Maggie Johnson, is EPA, she meant DTSC, looking at the Safer Choice certification program as a way to assist industry in waste reduction efforts?
Oh.
So it's basically there were 2 questions in the Q&A that Maggie meant to say DTSC instead of EPA, so we're kind of combining.
I can take that back. That's in our Safer Consumer Products group. I can take that back to them. I'm not sure, Maggie. I am familiar a little with Safer Choice. I've heard of it at least. Yeah, but for DTSC, I'll have to take that back to our Safer Consumer Products group.
Thanks, Ryan. From Marty Walters, in your research, did you find any significant differences between the waste being shipped to cement kilns and other combustors versus permitted RCRA Part B incinerators?
So that was not something that I looked at specifically. That's a very interesting question, though. If certain waste types are more likely to be shipped to the cement kilns versus the incinerators? That's an excellent question, but that was not an area of research. Could be an interesting path though forward going into the next reporting cycle.
Mhm.
From Eric Nolan, are there grant or other financial programs that could lead to research into treatment alternatives at some of our universities?
I think there are probably on the federal level currently. It's something that we're wondering about also, and so it's possibly one issue that we're facing, Eric, is resources. So this is an area that we're currently working in and trying to develop. Just in general, the waste reduction piece. So grants and other financial programs have been used in the past. The P2 program had a grant program. For us, it's a matter of resources and how that would be structured if it was to be redeveloped.
Yeah, and I just want to note that there are some financial programs that only focus on the reduction of hazardous waste versus looking into alternative treatment methods for hazardous waste. The former P2 grant program, though, did look at both and funded grants both for alternative treatments and for reduction. But yeah, as Ryan mentioned, I'm not sure about what programs exist right now.
A question from an anonymous attendee. You have noted that California faces severe hazardous waste management capacities and capabilities. Meanwhile, there are significant pushback against renewing existing hazardous waste management facilities, parentheses, not permitting new ones, close parentheses. Are these concerns being considered by DTSC's Board of Environmental Safety? If so, do you know how are they factoring this in their decision-making process?
Take that and we can add in. So I'm going to start at the beginning. Noted that California faces severe hazardous waste management capacity or capabilities. I don't know if that was the takeaway. There are certain waste streams where capacity in state is limited, and for this waste stream, for example, it's shared nationally. As you saw on the map, there was a number of facilities of incinerator facilities. Those facilities have seen a capacity issue, but we've also heard that it's starting to be resolved. Most of the treatment and management actually happens on site. So what we're talking about here is off-site management and manifested waste. On-site management is not manifest waste, so it's a different waste stream. So when we look at these two waste streams, and in total for manifested waste, there's typically about 1.5 to 2 million tons manifested off-site each year. When you look at on-site management, annually, our calculation and has been about 13 million tons are treated on site annually. That's a big difference. So there's a lot more waste management happening on site than it's being shipped off site. So I wanted to just clarify that. Meanwhile, and then I'll go into meanwhile. There are significant pushback against renewing existing hazardous waste management facilities, not permitting new ones. And are these concerns being considered by DTSC's Board of Environmental Safety? If so, do you know how? Oh, my internet just crashed. Sorry. Do you know how what they're considering? I think was the end to that question. I can't speak for the Board of Environmental Safety's considerations for that. I'm sure we can talk to them about it, but we haven't talked to them about that specific question.
From Drew Potts. Are there any plans to build or expand the ISQO facilities?
So, not that I am aware of is the short answer. The facility that we visited, they manufacture the equipment, but they do like tests and demonstrations. They are not building SQO facilities themselves unless other companies come to them and say they would like to order a SQO unit for their use. So I'm not currently aware of any plans to build or expand the SQO facilities. As I mentioned, in state, if you were using them for hazardous waste, they would require a hazardous waste management permit. However, if they were not being used for hazardous waste, then they would not require DTSC permits.
A couple of the applications that we heard of was for PFAS and it was in wastewater treatment plants. Heard of a couple of locations doing pilots to test that out.
Okay, from an anonymous attendee, are medical waste incinerators also experiencing backlogs? And if not, is that an option for some hazardous wastes?
I'm not sure.
Yeah, I'm not sure of that either.
From an anonymous attendee, are there any new haz waste incinerator facilities currently under construction?
I haven't heard of any other than the expansion that was recently completed.
There was a recently completed expansion. I'm not sure if there have been any completely new facilities that have been proposed or approved of. There are certainly none in California.
Also from an anonymous attendee, and I can go ahead and take this one. What is the status of the recordings of these workshops, particularly this one and the last one? This one is being recorded as we speak, and it will be downloaded and posted as soon as we can get it up. We just need to get it over to our internet publishing office, our comms office, excuse me. And the last one should be up, I think anywhere, I'd say you should go ahead and check by the end of this week. If not next, it should be up pretty shortly there. That one was recorded successfully, as well as the others that are all up.
It will be one writer.
Will be, okay.
From Eric Nolan. So how will the problem of incinerable waste be addressed in the plan? Will the plan simply present the metrics, or will there be actionable recommendations?
Sure. First, sorry, I'm rereading. Addressed in the plan. So we're going to be talking about identifying it as a waste stream to reduce. We need to go and look at the different industries, the different processes, and the potential for reduction of that waste stream. And that's what our plan is looking at doing. Is how do we develop the approach for that, and then what are we going to go and look at for incinerable waste? In the future, we're hoping that waste stream itself in particular would be one that a potential waste reduction strategy or group may be able to tackle. We're going to be taking steps in that direction, but initially that's what this first plan will cover. It's also a new reporting cycle is coming up, so that will also lead to additional research. Do you want to add anything?
Yeah, I think you pretty much covered it, but yeah, it requires it. The actionable recommendations are to continue to research this stream and develop a path towards DTSC being able to assist in reduction. To be able to have direct recommendations for reduction of incinerable waste requires a deep understanding of the industries generating these types of waste and potential alternative treatments. So that is an area of continued research as we move through future reporting and planning cycles.
It also touches on, I think, some of the source reduction information that we're trying to gather. In one of our other workshops, we talked about source reduction reports from SB 14 and how we went through an evaluation to identify those as the best source of information for source reduction, rather than TRI or the biennial reports. And so that took up a chunk of time to go and hash through what the differences are in the TRI and the biennial report compared to SB 14, and then coming up with some kind of approach to collecting those reports. There's thousands. And so collecting them is one thing to try and quantify source reduction. And then you get into the work part where you have to go and dig into the reports themselves and understand what the generators are doing. And those generators will vary from one to the other. So it's a bit of a task that we're trying to wrap our heads around how best to do that with the resources that we currently have. And so it's Eric, I think the start of it is understanding what information resources are out there, what are generators currently doing, and what does the landscape look like for generation in that waste stream. Alejandro, I think
we do have a question here that is in the chat, also from Eric Nolan.
Okay, yeah, I was going to say.
ISCO seems to have limited evaluation as to byproducts. Any plans to study possible effluent efficiency of products other than PFAS?
Alejandro, I think he also had a question right before that.
Let's see.
Curious about.
Quo sounds promising for hazardous waste treatment, but curious about energy use.
Yes. Yeah, I can address that. So that without getting into specific numbers about energy use, the energy use is primarily getting the SQO system started up into those conditions. And then once it's at steady state conditions, it actually uses relatively little energy. And again, I'm speaking in generalities, not in specifics here. It also could vary by waste stream. So it's not as if it is always intensively using energy. The energy use is economized if you're running at steady state and only need to use substantial amounts of energy during the startup portion. With regards to the second portion of the question, where ISCO seems to have limited evaluation as to byproducts and whether there are any plans to study possible effluent efficiency of products other than PFAS. It does, I agree, it does seem like ISCO has limited evaluation as to the byproducts. General Atomics is a demonstration facility, and it requires a company to come to them and say, here's our waste streams. We would like you to evaluate what the byproducts would be for these specific waste streams. So it would be, there could be a potential study of effluent efficiency outside of PFAS, but it would probably take having specific waste streams in mind to do those studies.
Okay, and I just wanted to address Eric Nolan again in the question and answer. Thanks again for putting your comments and questions in the Q&A, Eric. Thank you for the response on my question. It seems that to conduct the studies and evaluations on incinerable waste alone will require significant DTSC resources, not to mention the other major topics. How will DTSC garner those resources? Okay, you pretty much addressed that question. Thanks, Eric. And it looks like with that, we do not have any other questions in the Q&A box.
Okay. We did receive a couple of comments prior to the workshop. I did want to acknowledge those. And of course, I closed my window on them. There they are. Okay, so first, The first one, it was a goal. Goal was to be familiar with current discussions about this technology, since my company aims to identify key waste incinerator partners around the world. Another one was waste incinerators have closed in California. Where does the hazardous waste go now? And then the last comment was we need to modernize hazardous waste management in California. Wanted to acknowledge that we did receive those. And additionally, as always, thank you for all of the questions. It's very helpful for us to get these. I think we took a lot of questions back that will help us go, especially in the next reporting cycle, look into this waste stream more, and some questions that we should try and answer. In addition, some of the other feedback or comments that we've received from previous workshops was about identifying or organizing things, the data by the size of the generator, so LQG, large quantity generator, versus the small quantity generator, so LQG, SQG. We think this is the type of application where that's much more appropriate, diving into these specific waste streams, and it's why. I mean, you can look at the waste management system as a whole and understand it there, but that's been done quite a bit, and we hadn't broken it out really by the RCRA, non-RCRA. So we felt that was we wanted to look at that, and then when we took a step into the waste, the specific waste streams, going into the LQG and SQG would really help us, one, kind of categorize them that way, try and target bigger ones, because bigger ones will have different issues than smaller ones, and then you can go and look at smaller ones and work on reduction for both. But those two types of entities are going to be different, and so it's a way to organize the data that we're looking at and develop a strategy. So I did also want to highlight that those types of comments about the data organization and LQG, SQG in particular, wanted to point out that this is where we thought and had been intending to apply that approach. And so thank you for those comments, and hopefully that this was helpful for us to show how we've been using it. Okay. I don't know. I don't see any other questions or comments coming in. So let's go to the next slide. We're just, yeah, so we'll go ahead and, no, that's good. Thanks, Karen. Yeah, go to this, the schedule. Just wanted to remind on the next workshops, November 6th, we're having modern landfill design, operation, and opportunities for alternative management. November 13th, we have advancing environmental justice, examples and opportunities for integrating environmental justice in DTSC's programs. And then November 20th is our last one to close it out. We have modernization of analytical test methods and updates to regulatory references. Each one will be interesting in its own right. We're looking forward to these last three, and look forward to your participation, questions, and yeah, saying hi. So next slide, please. And lastly, for further information, you can scan the QR code. It'll take you to our website. Website's also listed up here. You can join our e-list for updates. And as always, you can email us at dtsc_hwplan@dtsc.ca.gov. With that, thank you for the attendance. And I wanted to extend a thanks to all the support, our slide driver over here, and our interpreters. Thanks again for all the help, and Alejandro. With that, let's go ahead and close it out. And thanks, everybody.
Thank you.
See you next week.